Number 14, a police officer is using a radar device to check motorist speeds. Prior to beginning the speed check, the officer estimates that 40% of motorists will be driving more than 5 miles per hour over the speed limit. Assuming that the police officer's estimate is correct, what is the probability that among 4 randomly selected motorists, the officer will find at least one motorist driving more than 5 miles per hour over the speed limit? There's a few different ways to approach this problem. You can treat this as a binomial. You have a set number of people being sampled with a percent of probability of success, and you have what we're trying to figure out, a value from that. It does not have to be done as a binomial either. All right, have you tried it? Pause the video if you want to try it. Here's one way that I do it. Okay, so I think about this problem without having to do a binomial, where the speed of going 5 miles, the speeding is 5 miles per hour over. That probability, the officer estimated at 40%. So I'm going to write 0.4 for that. I'm going to let X be the number of motorists out of 4 driving over that 5 mile per hour. Now, what we want to do is we want to picture what's happening here. The probability of at least one motorist driving more than 5 miles per hour is the probability of 1 driving more than 5 miles per hour, plus the probability of 2 driving more than 5 miles per hour, plus the probability of 3 and the probability of 4. So this is 1 out of the 4, 2 out of the 4, 3 out of the 4, and 4 out of the 4. This can be done as a binomial. To do a binomial, you do second vars, and you can do binomial PDF or CDF. Let's do PDF first. And you can do this with me. This is 4 trials. The probability of success is 0.4, and that first one is going to be 1. So I'm going to jot that down up here. That's going to be approximately 0.3456. And then we can repeat that process, and each time we can change the number. So instead of having 1, we can go up and do 2. Now I'm just going to scroll up and edit the 2 there instead of going into the binomial, but it's the same thing for 2, 0.3456. And we'll do 3. 0.1536, and we'll do 4. 0.0256. So let me write those things down. 0.1356, 1536, and 0.0256. So if you add those 4 numbers together, you would have your answer. So this is, by the way, the long way. But as a binomial, the long way to do it, it might make sense, at least conceptually. So I wanted to make sure that we had that option first. So it's about 87%, right? The probability of at least one motorist driving more than 5 miles per hour is 87%. You could also do a binomial CDF. The way binomial CDFs work is it always goes to the left. So if you have 4 trials, your probability is 0.4. If you put your X value as 0, then it's going to do the probability of it being 0 unless, well, just 0. That means the probability of none of the motorists getting, of those 4 motorists going over 5 miles per hour But then you have to subtract that from 1. And you get 87.04%, 0.8704. So it can be done as a binomial CDF as well. But that's not how I do it in practice. In this problem here, it says the probability at least one motorist is the same as the complement of none. So if I think of this as, all right, what the probability that none go over is going to be 1 minus 0.4. The probability that none that not one goes over is not 0.44, it's 0.6. So we have 4 different people, so we're going to raise that to the 4th power. So 0.6 to the 4th power is 0.1296. That's this number here. Same number. So now if I subtract that from 1, you'll get that 0.8704. So you don't have to do this as a binomial. You can, but you get the same thing whether you do binomial and add them together, binomial CDF and subtract it from 1, or straight up just getting the complement, raising it to the 4th power because we don't want any of them getting the ticket, and then subtracting that from 1 to get your complement.